All right, so now we are going to look at density, and density has two components, I believe. You have to actually understand what it is in terms of the concept, and then the math, because the math can be a little tricky if we're not understanding the concept. So let's look at this. I think we've had this riddle, I guess it's considered, what weighs more, a pound of bricks or a pound of feathers? And obviously they weigh the same. But the density, though, is different. So a pound of bricks, maybe I'll need this much to weigh for a pound, but a pound of feathers, I'm going to need a container that's going to be quite larger to make this weigh the same as this. So feathers do not have a high density, because density is defined as the mass per amount of space it is, okay? So mass per space, okay? And space is considered volume. So we all have space we occupy, that's volume, okay? And mass is the other stuff that actually has the weight part component of it. So if we talk about a pound of bricks, this is the mass, a pound, right? And a pound of feathers is the mass per volume. So which one has a bigger volume? This would be, the feathers would, right? So we have less. So why would it be, so this is going to be actually less dense because we have more space. So density, I guess the best way to consider this is, let's just kind of take, if I took one chunk, all right? If I took a chunk of that, and let's just say I made it a cube, right? I took a chunk, and I have it, it's 1 inch by 1 inch, so I'm just going to go, it's 1 inch by 1 inch by 1 inch, okay? So I have this cube, it's 1 inch by 1 inch by 1 inch, and then I'm going to take a little chunk of this guy too, and I'm going to take the same box, the same size, so I'm going to go here, and I'm going to go 1 inch by 1 inch by 1 inch, so this is the same thing, 1 inch by 1 inch by 1 inch. So they're both the same amount of space, so space is the same for these, but which one would have more mass to it? And the brick obviously would. So basically we can look at this and say, if I can keep the volume the same, so if I take a chunk of something and another chunk and the chunks are the same, which one would weigh more? And that would refer to your density, okay? Because density is equal to your mass, which is usually grams, okay, over your volume. It's an equation, okay? And volume is either milliliters or centimeters cubed. This is inches cubed, that's another measurement, but the most common ones would be milliliters for a liquid, right? And a centimeters cubed would be more if I'm measuring a solid, okay? You know milliliters, if you look at your soda bottle or something, you look at it, it has a measurement in milliliters because it's a liquid. If you look at a solid, you're just going to be measured in dimensions, like inches or centimeters. So the most common dimensions are milliliters and centimeters per volume. If I step on a scale, I usually get pounds, right? Well, the most common measurement in science is grams instead of pounds. So grams over milliliters or centimeters, okay? So if we look at this in terms of the chunks and how much they weigh, then we can see, okay, it's mass divided by the volume. So if I have a big volume, a big amount of feathers, right, a big amount, that's going to make the number less, because this is the denominator and this is the numerator. So if I make the number less, so for example, if I go 1/3 versus 1/6, this is smaller because I made the denominator bigger. I made volume bigger, therefore the density is going to be less versus something that has less volume and the same mass. So pound, we can say 1 pound, 1 pound, but let's say the volume here is 3 centimeters cubed versus 6 centimeters cubed. Obviously the density is bigger here because you have smaller volume, okay? So we can look at that in terms of math now, but hopefully the concept is there. So you can look at like why a rock will sink in water versus why a ship will float. So let's look at that before we get more into the math, right? So if we look at a rock at the bottom of the water, so we can just say we have a pool, right? And we have a large rock at the bottom, but then we have a boat that is floating at the top of the water, the pool or whatever. So this rock must have a higher density than the water versus the boat has less density because it floats. So floating and sinking is related to the density of what it is, okay? So water, for example, is 1 gram per 1 centimeter cubed, or 1 milliliter. Since we're doing liquid, I got to be consistent, right? So we're going to say 1 milliliter. So obviously this has a greater density because it sinks, and this has a less density. Now, that doesn't mean that this is less massive. It can have a lot of weight. This boat can weigh more than the rock, but it's got a bigger volume, because then if you have increased the volume, then therefore you're going to have a less density. So you have lots of mass spread out in a large amount of area, making the density less. And while you have a lot of mass in a small amount of area, making the density more. And therefore it's going to sink. And then you're just comparing it to the density of water. Okay? So looking at that, we can look at the math part now. I think the common mistakes we look at this is our units. Okay? Our units must be very similar. You should know what the units mean. So if I have a number and it's in grams, you have to automatically think mass. Okay? If I say, if I give you a number like 10 milliliters, okay, or I give you a number like 20 centimeters cubed, those two refer to volume. So you have to look at the units, I'm underlining the units, to know that. The last one is a number where I have grams over centimeters cubed, or I have a number that is grams over milliliters. Both of these would be related to the density, okay? So that is the biggest concept with the math here. So for example, I'll just write a number here. Actually, I'll do it right over here for my example. Let's just say I have 20 centimeters cubed, okay, and 10 grams. The density is what, right? What is the density? Now, don't just say, oh, it's mass divided by volume. It's the first number divided by the second number. No, 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 no. It's the G divided by the ML or CM. So you have to look, okay, mass is the top number. So I'm going to have grams on the top, and since this is in centimeters cubed, I'm going to have centimeters cubed on the bottom. Now put the number with it. Grams is 10, and 20 is the centimeters cubed. You have a half a gram per centimeter cubed. And that's how you find the density. So make sure you associate your numbers with the correct unit, with the correct meaning. A lot of common mistakes is we see G and we go, oh, it's the second number, that is our volume. No, no, no. Make sure you look at the letter after it and see what it is referring to. Okay? And then you can do your math rather simple because you just plug in the numbers related to this equation here. Alright? So hopefully you kind of understand the concept of density, but also looking at the math and how the equation is related to the units. Okay? Good luck.